All right, so the supplies that you're going to need for this will be your lab notebook and something to write with. And what I'd like for you to do is to go ahead and open up to your table of contents. When you open up to your table of contents, you'll see the next available page, what needs to be included. It's a velocity equation, Cornell notes. Many of you are already familiar with Cornell notes, which is great. For those of you that aren't, I'm going to go through just a few key things because we're going to be doing Cornell notes directly into our lab notebooks. Now, the Cornell notes paper looks like this. However, we're not going to be using Cornell note paper. Rather, instead, we're just going to be writing it directly into our lab notebooks. So there's a topic or objective. There's a date. We're not going to worry about those two. You have the EQ or essential question. And then we divide our paper up into questions, notes, and at the very bottom of the page, you're going to see a summary section that looks like this. Once again, I'll go over that in more detail. Now, when you finish with your Cornell notes today, these color code kind of lets you know what it will look like. You'll have your learning target across the top, and then in the green section is what you're going to be filling in. These are all the notes that you're going to be taking. In the red section, those are going to be review questions, review points, or perhaps even test questions that you think I might ask. And at the very bottom, the purple section is the structured summary. Now, before we set up our Cornell note paper, there's a couple things we've got to look at is what do you have to do in the beginning? The first thing you have to do is you have to create your format. So before the lecture begins, and I'll put the format back up again, you're going to go ahead and create the format. What you do is you have your heading, essential questions, and you just break it off into those columns. During the lecture, you're going to organize your notes. And so you're going to record information that I am including. You're going to leave some spaces, abbreviate. Feel free to bullet, change colors, use signs, notes, indentations to help you. So let's get our paper set up. So across the top, you want to go ahead and write our topic or objective. Our topic objective is going to be velocity equation. And then today's date, 10/23, or if you're in the B days, it would be 10/25. 10/26, sorry. Now, the middle section here is going to be your EQ, or essential question. Your essential question is, how can you calculate velocity without having to use a graph? How can you calculate velocity? Notice I'm using the symbol for velocity without a graph. Now, we know how to calculate it from a graph because we have set that up, and we're going to talk a little more about that. And the next thing I want you to do is go ahead and divide your paper into these two columns. Okay? You have a small section for questions, small section for notes, and then of course you can save room at the bottom for the summary if you'd like, or you can wait and put the summary at the very end, depending on if you use more than just one page. All right, so let's go ahead and take a look at our graph here. One of the things that you're going to be doing is you are going to be sketching some graphs in your notes section. So go ahead and sketch this graph. If you notice, we have a position time graph. Our position is measured in centimeters. Our time is measured in seconds. Now, yesterday in class, you learned how to describe the motion of an object. So if we describe the motion of the object in words, we're simply using the yellow sheets that are at the front of the classroom and those 5 things. So our starting position, if we look at our graph, is going to be 400 centimeters. And I can tell that from the y-intercept. Notice I'm also using xi as my symbol. I know that my direction of travel is a positive direction. I know that it's a positive direction because it's a positive slope. I know that it is a constant velocity. I know it's a constant velocity because it is a linear line. If I had curves on it, then I know it would be changing. My velocity is not changing. I know that my amount of time that I am moving for is right here, 80 seconds. Make sure you include your unit there. Now, the last thing I left off was the velocity. The reason I left off the velocity is I don't want to just say it's fast, medium, or slow. I want to go ahead and calculate the velocity. Now, you already know how to calculate velocity as the rise over the run. So if I pick 2 points along my line, I'm going to pick this one and this one. I'm going to shade in my rise. I'm going to shade in my run. My rise in this example is going to be 400, and my unit is meters, centimeters, and my run is going to be 80, and my unit is going to be seconds. The reason I know that it's going to be 80 seconds is because that is my unit down here for time. Now, what I'm going to do is I'm just going to simply calculate what that number is. And one of the things that's important is making sure that you include your units on there. And so I'm going to take my rise, which in this case was 400 centimeters, and I'm going to divide that by my run, which is 80 seconds. So when I calculate 400 divided by 80, I get 5. And the unit is centimeters per second. That number right there tells me my velocity. That is the exact speed that I am traveling plus direction. Remember, velocity includes both of those things. Now, what I want to do is I want to go through a kind of a derivation of how we can get these numbers so that we don't always have to rely on a graph. Okay? Now, we know the velocity on the graph is rise over run. That's what we just calculated right there. Okay, so we know that. We know another way that you can find the velocity on a graph is to just tell me two things. How far the object goes, which in this case was 400 centimeters, and the amount of time it travels. And once again, in this case, it was 80 seconds. So that's a second way that you can figure that out. Now, a third way is to actually use the graph in the equation, okay? So if you take a look on the calculation of the velocity, this equation does not rely on the graph, but we can see where those numbers come from the graph. So again, we have, it looks a little offset, I apologize for that. We have XF, and XF is new to us, but if you think about what XI means, XI is initial position, XF is final position. And then we have XI right here, and then we have delta T. Once again, I apologize for the delta T being offset. Now, if we take a look back up here at our graph, what we want to do is see if that matches what I did. I'm going to use green. I know that my XI right here, I'm going to try to use green. Maybe I'll use black. My XI right here was 400 centimeters. My XF up here was 800 centimeters. Now, based on that, all I did was subtract. I took my XF and I subtracted it from my XI, which is how I got 400 centimeters in the first place. Now, it's really, really important to make sure that you always subtract XF minus XI. If you don't do that, then you'll end up with a negative number when you don't intend to end up with a negative number. Okay? Now, the next thing that we want to look at is another way to write this. And once again, I apologize, it's kind of offset. And it's right here. So right here, I have my delta X, which we already know is XF minus XI. And you divide that by your time. And in this case, it's 80 seconds. And once we have our formula, then all we've got to do now is have a word problem. We don't have to have a graph anymore. Now, I'm going to go over a few things that are important when we do calculations in physics. By doing it right now, it will help whenever you have more difficult problems. Well, first thing we always do is write down all of our given information over on the left-hand side. We write down what our unknown is. So our unknown in the case of velocity, we just say unknown is velocity is our question mark. We would write down the formula that we're using, and we know now that the formula would be XF minus XI over delta T. We would make sure we include the numbers in that formula with units. You absolutely cannot drop your units when we do these calculations. And then we calculate the answer with the correct unit. Okay. Now, as far as rounding goes, we always round out to the hundredths place, so 2 decimal places, and then just circle it at the end. So what I've done for you here is I've just simply provided an example of what I would expect. All of this is to guide you. You don't have to write all of what's in the circle. Rather, instead, what you're writing is what's on the right-hand side. So here's our given information. I know that a horse is traveling 20.1 miles in 0.52 of an hour. We want to know what its velocity is. Okay? Now, in most word problems, we assume the object is going in a positive direction unless stated otherwise, or unless the numbers provide otherwise. So if we take a look at what our given information is, xf is given, xi is given. We assume that xi is going to be 0 unless it is stated otherwise. Okay, so that's an important piece. The other thing is we know what our time is. Our delta t is 0.52 of an hour. So that's step 1. Step 2 is what is our unknown. And our unknown is velocity. So I've written that here. Our v is our question mark. Then we write down our formula. It's your choice which formula to use, whether you want to write it this way or you want to combine it and write it that way. Either one is completely fine. Then you write in your numbers. When you plug in your numbers, you plug them in with the unit. Make sure that those units are always there. And the last part is the math. And no doubt you can do the math. I'm not worried about that, but I do want to make sure that you include the unit on there as well. I know it's miles per hour, simply because it is my rise unit over my run unit. Rise over run from the graph, it's the same as when I do a calculation. Now, where people usually mess up is not with the calculation of the math, it's with all the units that go with it, because many of you, that's a new thing to have to include. So what I want you to do now is to go to my homework and find the velocity calculations, import those, and you can start working on them now.